All right. Hello, everyone. This is a video on trigonometry, the law of sines. So let me zoom out here a little bit. Try that again. There we go. All right, so the law of sines. So the law of sines says that for some triangle, let's draw a general triangle over here. So we'll call this angle A right here. So that's angle A, that's angle B, and that's angle C. And typically the way we name the sides is the side across from angle C is side little c, the side across from angle A is side little a, and the side across from angle B is side little b. Like that. All right. So the idea is this. This is not a right triangle. All right. So this is just a non-right triangle. I guess you would call that an oblique triangle. So the sine of angle A over side A, right? So the sine of this angle over this side is equal, that ratio is equal to the sine of angle B over its opposite side, which is also equal to the sine of angle C over its opposite side. All right, and that's always true for any triangle, although there are some cases that are what we call ambiguous. So there is one situation where it depends on the situation. So, so here's an example. Well, before I actually give you an example of the problem, let's talk about why this is true. And I can sort of give you a partial proof. So, partial proof of the law of sines. So, you know, from any angle in a triangle, if you draw a line perpendicular to the opposite side, you create an altitude, right? So this is perpendicular. So you can draw a line straight down perpendicular, and we'll call this side h for the height. All right. It looks a little crooked on the video, but it okay. Anyway, it's a little janky, but so if this is a right triangle, then it's automatically true. From our what we learned with right triangles is the sine of angle A is equal to opposite over hypotenuse. That'd be h over b, right? But also the sine of angle B is opposite over its hypotenuse, because this is a hypotenuse of this right triangle, and this is the hypotenuse for this right triangle over here. So the sine of B would be h over a. All right, now I can solve this for h by just multiplying both sides by b. So b times the sine of a is h. But also, a times the sine of b is h, right? And we know that this is equal to this because they're both equal to h, aren't they? So if h is equal to b sine of a, and h is also equal to a sine of b, that means that b sine of a has to equal a sine of b. And if I divide both sides by the product of AB, then these b's cancel, giving me sine of a over a equals, these a's cancel, giving me sine of b over b. And there's one of the two, the first two ratios, right? Now, you could also draw a different altitude over here Right? You could draw it like right there would be the altitude. And then you could show that the same would be true for sine of C as well. All right, so that's a partial proof. It's not a whole proof, but it gives you a general idea why it's true. All right, so let's talk about the different uh, examples here. So you need three parts of a triangle to determine a triangle, right? So if you remember, one situation is angle side angle. That means you've got two angles. You know two of the angles in the triangle, and you know the side in between those two angles. We call that the included side. So here's an example of that situation. So let's say this is a 75-degree angle, which it obviously isn't, but let's pretend it is. Okay. And this would be C, this will be B, and will give us this side right here, and this will be 340. And I think I got this out of the book, the textbook, and this is actually miles. And I think you're looking up here at a satellite or something, right? So you have a town right here. I think this is like LA, Los Angeles. And you have somebody over here 340 miles away looking up at the same satellite. So this person in LA looking up the satellite has to look at a 75-degree angle from the horizontal, which is here. And this person looking up at the satellite has to look up at a 60-degree angle from the horizontal. So if they're 340 miles apart, I think the question is, what is this length right here, which we'll call B, right? So we're looking for side B. So find side B is the question here. All right, so using the law of sines, we could say, well, I want to say the sine of this angle over that side equals the sine of this angle over this side. The problem is that would give me two unknowns, right? So if this is side A, we'll call this little a, and that's really no good, right? Because I would get the sine of this angle over this side. That's an unknown equals the sine of this angle over this side. A second unknown, I don't want two unknowns, I only want one unknown. But the nice thing is, since I have two of the angles in the triangle, I can go ahead and find that third angle. Because you know that all the angles in the triangle add up to what? They add up to 180, right? They add up to 180. So the measure of angle C has to equal 180. Take away this angle, take away this angle, and that comes out to be 45 degrees. Okay, so now I can go ahead and put that up here. So now I got an angle and its opposite side, which is perfect. That's what you want for the law, right? I want an angle and its opposite side, if possible. So I can say that the sine, and of course, since I'm looking for B, I have to use this angle here. So I'm going to do the sine of 60 over its opposite side B equals the sine of 45 over its opposite side 340, like so. All right, now I have to solve for B. And since these are two equal fractions, remember, whenever you have one fraction equal to another fraction, then their cross products are equal, right? So what I mean by that is, let's say I have 1/4 equals to 2/8. We know those are equal, right? Because 1/4, 2/8 reduces 1/4. Whenever you have one fraction that's equal to another fraction, when you cross multiply, you get equalities, right? So 1 times 8 is 8, and that's equal to 4 times 2, which is 8. Okay? I should write it like this. So 1 times 8 is equal to 4 times 2. And that's always true with equal fractions. So since I have two equal fractions here, then the same is true. B times the sine of 45 is equal to 340 times the sine of 60. Okay, now we just need to figure out what is the sine of 45 here. So I'm just going to get my calculator out. So the sine of 45 is 0.7071. And the sine of 60 is 0.866. All right. So now I just need to divide both sides by 0.7071. And those cancel, right? And that gives me B is equal to, and when I do all this math, let's see, 0.866 times 340 divided by 0.7071 is about 416.4 miles. So 416.4 miles. Okay. So that's an example where I had an angle, a side, and the other angle, and the side given is in between the two angles. All right. Let's do another example. Example 2. So this A, and angle A is 20 degrees. This side given is 80.4. This is B. This is 25 degrees here, and that's C. And we don't know A, and we don't know B, little b. So we don't know side A, we don't know side B. So what we're going to do is just find everything we can, right? So it's called solve the triangle, right? So what am I missing? I'm missing this angle right here. So I'm going to find the measure of angle B, find side A, and find side B. All right, so those are my goals. All right, so let's see what I could do. I could very quickly find this angle. That's not a big deal because I've got two of them, and those add up to 45, right? So, and all three have to add up to 180. So the measure of angle B is going to be 180 minus 20 minus 25, right? So that's 160, 140, 135 degrees. All right, so I found angle B is 135 degrees. Okay. Now let's find, I don't know, let's find one of the sides. All right, how about we find side A? So to find side A, I would just do the sine of angle A, which is 20, over A equals, and I'll use side C next, so find the sine of 25 degrees over 80.4. And I chose this because I know the opposite side. I don't know the opposite side here, so I don't want to have two unknowns in my equation. I just want the one unknown, in this case side A. All right, now I'm going to cross multiply, so A times that, and then 80.4 times that. Okay. And now I can just divide by this, right? So it would be, when I divide both sides by the sine of 25, I get A equals 80.4 times the sine of 20 over sine of 25. All right, let's put that in our calculator here. 80.4 times the sine of 20 is that, divided by the sine 25 is about 65, 65 point, I'll go out to here. So A is about 65.0668. All right. Now I have to find side B. I'll do that over here. Find side B. No, side B would be. All right. So to do that, I'm going to do the sine of 135 degrees over side B equals the sine of 25 degrees over 80.4. All right. Now we just cross multiply. So B times the sine of 25 equals 80.4 times the sine of 135. Divide by sine of 25, so B is 80.4 times the sine of 135 over sine of 25. Let's see what we get with that. About 134.52. 34.52. All right, so I found all the missing pieces, right? I found side B. I found side A. And I found angle angle B right there. And therefore I solved triangle. All right, so let's talk about the ambiguous case here. Now, what was I given here? That right there was an example of angle side. Because I was given an angle or side angle, the same thing, right? Because you're given a side, and then you're given an angle, and then another angle over here. And the side is not in between the two angles, right? I was not given this. But if you're given two of the angles, you can find the third angle, and then you've automatically got angle, side angle, right? So angle, side is always comparable to angle, side angle. Does that make sense? Because if you know two of the angles, you automatically can find the third. And if you can find this one, then you've got two angles with the side in between. All right. This next case, though, is called the ambiguous case. And it's side angle. All right, so let's talk about why the other two always determine a triangle. So with angle, side angle, or side angle, the triangle is determined and therefore unambiguous, right? So by determined, I mean there's only one triangle you can draw. So let's talk about like angle side angle. So you've got this angle. Let's say you've got like an angle right here. Let's say it's 30 degrees, okay? And then you've got a side that's attached to that angle. And we'll just say that that's 10 whatever, 10 inches, 10 feet. And then you've got this other angle. Let's call it, I don't know, right here, we'll just call it like 40 degrees. So you got angle, and then the side, and then the angle that attaches to the other end of that side. Now, that angle's set, so this has got to go out this way. And that angle's set, so this has got to go this way. So they have to meet right here. Therefore, that's the only triangle you can draw in that situation. So angle side angle is fixed, right? There's only, if I give you this information just like this, you and I will both have to draw the same triangle, right? We know that this is 70, so this angle right here is going to need to be like, I don't know, 70 from 180 would be like 110. I know this isn't right, but I did not estimate those angles very well. But anyway, it's set. All right, the same is true with side angle, although it's not as clear. So side angle means you got this side. Let's say down here you've got a side, and that side is 10, let's say. And then you've got an angle off that side. Okay? Let's say that's 60 degrees. And then you've got another angle up here, not attached to this side, right? So let's do one right here. Let's just say it's 90 degrees. All right. But if you know these two angles, you know that angle too, right? Because if that's 90 and that's 60, then this one's got to be, what, 30? Okay, so this one's got to be 30. And if that one's 30, then you're back to this situation here. So this one's set and this one's set. So again, it's fixed, right? Side angle automatically leads to angle side angle. Okay. So, however, let me get another sheet here. So, side angle, however, can be ambiguous. Okay. So, here's a side. Let's say it's 10. And here's a side. Let's say it's 7, right? And then you've got an angle here. Let's say it's 30 degrees. All right. So this angle's fixed. This side length is fixed. This side length is fixed. Now this side has to extend over here, but we don't know how long it is. Nothing say it's that long. Well, there's two triangles I can draw here. This side could go this way, but I could draw another one that looks just like it with the same information, right? So let's say, again, you've got the same situation where this is 30, this is 10, and this is 7. Right? Got the same exact information, two completely different triangles. So in this situation, this side doesn't have to go here. It could go this way, right? Now, the key to remember here, the thing you need to remember is whenever you've got these two angles like this, these are called supplementary angles, called angle X, angle Y. And you know that angle X plus angle Y have to add up to 180 because together they make a straight line, right? Same here. Here, X and Y would just be switched. If Y is the bigger angle, then that's going to go on this side over here, right? So same situation here, x plus y is 180. Right? So if you think it's this situation, right, you're going to pick the smaller of the two angles that add up to 180. If you think it's this situation, then you're going to pick the bigger of the two angles that add up to 180. So let me give you an example. All right, so example 3. All right. So let's see. Actually, I'll just use the same information, right? So let's say got this side's 10. This is 30 degrees. And we'll do it this way, okay? And this is 7. All right. We'll call this side A. Angle A. We'll call this angle C, and then call this angle B. And I want to find angle B. Find the measure of angle B. All right, well, I can set that up like so. The sine of angle B over its opposite side, 10, is equal to the sine of angle A, which is 30, over its opposite side, 7. Okay, so just like before, we cross multiply, so 7 times the sine of B equals 10 times the sine of 30. And then I divide both sides by 7. So the sine of B is 10 times the sine of 30 over 7. Let's see what that is. When I put that in my calculator, I should get, I've done this already, you should be, yeah, I better show you. So 10 sine of 30 divided by 7, so 0.7143. All right. So the sine of the angle is this ratio. So therefore, the inverse sine of the ratio will give me the measure of angle B, right? So let's see. So the inverse sine of that ratio, oops, try that again, inverse sine of 0.7143 is 45.6 degrees. Okay, so this angle then is 45.6 degrees? Definitely not, right? That's an obtuse angle. So since it's an obtuse angle, to figure out what this angle actually is, what I just found is actually this angle, right? So this angle is 45.6 degrees. That's what it gave me. So I need this one. So I need to do 180 minus 45.6 degrees. So minus 180, I'll just ignore the negative. It's about 134.4 degrees. That's the answer that we're looking for. Right? So notice that when I worked it out, it gave me an answer, but it's not correct because I know this is obtuse. So there are situations here where you have to subtract. Now, if the triangle looked like this one up here instead of this one, then that would have been the answer. That angle would be 45.6 degrees, right? That would have been correct. But we're dealing with this situation, so I had to subtract from how to use this idea here and subtract from 180. Okay, so that is the side-side angle situation. So you just got to be careful with it. There's one other one. It's called the no solution case. Let me see if I can fit that in here. It's a no solution case. In the no solution case, basically, it sort of looks like what we've got here. Right, so you've got, like, let's say you have a 30-degree angle, and that's 10, but this side's only like 2. Well, it's not long enough. It's not gonna, it doesn't even touch, right? It doesn't even touch the bottom down here, this side that makes that 30-degree angle. So here's an example of that. Now, when you see it, it's not going to look like a no solution case because they're actually going to give you a triangle, right? So this is 122, this is 42 degrees, right? And we want to find the measure of angle B. So this is angle B right here. Call this angle A and this is angle C. So what is this angle? Well, to set it up, we say the sine of angle B over side B is equal to the sine of 42 over its opposite side. Okay, then we cross multiply. So 70 times the sine of B is 122 times the sine of 42. Now I divide by 70 to get rid of that. So the sine of B is 122 sine of 42 over 70. Let's put that in. Divided by 70. We get 1.17. Now, that's impossible because the sine of an angle is always under 1. It could be 1. The sine, like if you do the sine of 90, that would give you 1, but it's never going to get any bigger than that. If I do sine of 135, it's smaller, right? It's always smaller than 1, no matter what. The sine of 85 is smaller than 1. So you can't have the sine of an angle being bigger than 1. So this is impossible. Impossible. Since the sine of B, the sine of B is greater than 1. So no solution. All right, so that's it. I'm done. That is the, let me pull this back down so you can see some more of it if you need to. That is the lesson on the law of sines. All right, hopefully you took notes. Thanks for watching. Have a great day.